And I'm a solution specialist in our Houston office. Also with us today is Tony Echevarria, an application engineer here in Houston. He'll be doing the technical portion of our presentation today. To keep us on track, we want to take any questions that you might have through the chat window, and we'll address them immediately after we conclude our session today. Just make sure that whenever you send the message that the Send To box shows ECAD Inc., and that'll make sure it gets to the right person. All right, quick overview. Today we will focus primarily on three key areas. First, we want to show how easy it is to accurately predict movements of steered vehicles, including cars, trucks, buses, and planes. We also are going to take a look at how quickly we can evaluate design alternatives so we can optimize road and campus geometrics. And then we'll take a look at the significance of being able to perform real-time analysis. How quickly can we get feedback necessary to make the next design decision? And also, does our design comply with the accepted standards? We're going to do a brief demonstration. Tony's going to do that for us. And then afterwards, we'll summarize what we've covered, and we'll leave the session open a little bit long so you have time to submit some questions. Our goals for today is to get everybody some exposure to Autodesk vehicle tracking. We're going to review a subset of capabilities. Vehicle tracking has quite a bit that it can do. We're not going to have time to cover everything today, so we're just going to look at a subset. And by the end of this, hopefully everyone can understand the business benefit of using Autodesk vehicle tracking. So with that, we'll get started, and I'll turn it over to Tony for our demonstration.
Successfully maneuver from the southwest and then exit at the northeast of our project. I can do this by clicking the auto drive command, which will bring up our vehicle library. In here we actually have over 1,000 vehicles to choose from all across the world. But for our example, I'll use the ASTO design 65-foot conventional school bus. When I select my vehicle, off to the right we get a vehicle diagram, and in here we get specific information and dimensions about our vehicle. I also get a chassis view, and we get a profile view as well. So now I can go ahead and start. Now laying out our path will be as easy as just clicking points throughout our project. Once I start laying out these points into my path, you'll see a green envelope which indicates the vehicle body, and a red envelope which is created by the chassis. The envelope itself actually shows the horizontal space required to make the maneuvers. As I approach this roundabout right here, I might have to make more concise clicks so that I can make that sharp turn. Once I'm done laying out my path, I'll get intelligent grips from which I can use to edit my path. If I move a grip that results with a maneuver that my vehicle can't make, it'll stop making the envelopes at that point. So I can just go ahead and adjust that. And then I can continue making edits if need be. With our swept path done and revised, we can confirm that it will work horizontally, but we can also evaluate the path against a number of rules-based constraints. And we can do that by performing what is called a design check. When I perform the design check, you see we got a severe steering warning in here. What that means is that our path has a steering angle that is excessive of what is allowed. We can easily create a graph within our model that will display the steering limits and the steering angles that we made throughout our path. When I lay out this graph, we get to check out all the steering angles that we've made throughout our path. If I scroll over here to the right, this is actually a steering angle that coincides with the one in the roundabout. Now you can see that vehicle tracking can quickly and easily determine if our design can accommodate vehicle movement. So we'll go ahead and check out this next example I have for y'all. Here in this example, we're going to negotiate a site. We're going to try and confirm that a 30-foot delivery truck can successfully access the loading area of this commercial facility right here. So I'll go ahead and choose my vehicle again. I'm going to switch it up this time. And I'm going to pick an SU30 single unit truck for this. Now in the last example, we went around our path doing our points so that we can make it that way. But this time I'm going to switch it up and I'm going to have the system make some of those points for us. So it pretty much make the path for us automatically. I just need to do these first 2 clicks right here. And then I can tell it what alignments to base my path off of. And for the first alignment I'm going to choose, I'm going to click this center line right here. And then for our next alignment, I'll hit this edge of pavement over here. And then for our very last alignment, I'll pick the edge of the building right over here. Turn my snaps on real quick. And in literally just a few clicks, we've already made our path. And now, just like the last example, I can use my edits to edit my path if need be. But down here, it looks pretty good. So I'll go ahead and check out the north side of my drawing here. And right here, we can see that the vehicle might go off the roadway. And in the real world, the driver would probably, perform a steering overturn in this case. And we can simulate that by using this arrow grip right here and moving it over to the right. And then now our issue is resolved. Sometimes we have to present our project to a stakeholder, and usually that's a little bit easier if we show it in 3D. And we can go ahead and do that by creating an animation. So I'll do that right now. Once we create our animation, we can go ahead and start the playback. And then we can use these slider bars over here to the left to change our point of view. We can even check out the height from this angle. Now, as it approaches the turn, you'll be able to see that steering overturn that we simulated in our path. You'll see as the vehicle, it might slightly go out into the other lane and then it'll jump right back into its original lane. Then we can switch up the point of views. We can check out the driver's view here. And you can even switch it back to a fixed point. And then we can continue to edit the view here. And then once our vehicle goes into reverse, we'll be able to switch it to the driver's view and then even check out the side view mirrors. And when we do this, we can see exactly what the driver would as he's reversing onto the loading bay. So whether you need a 2D or a 3D visualization, vehicle tracking makes that process very quick and very easy. Now I'll go ahead and head over to the east side of this project. Now we can see this parking lot here. It needs some striping. And usually when we're designing these parking lots, we typically want to maximize the number of parking stalls, and at the same time we want to do something that's functional. So how long do you think it would take to design this particular lot to net the most parking stalls while at the same time abiding by certain parking lot standards? Fortunately, with vehicle tracking, we can figure that out pretty quickly. So I'll go ahead and first I'm going to pick the standard from which I want to work with. And just like the vehicles, we have a number of those that we can choose from. But I'm going to choose the US standard for mine. Once I pick my standard, I'm good to go, and I can start laying in my parking bays. This is going to be as easy as just going around my perimeter and clicking on some endpoints. Once I've clicked my endpoints here and lay down my perimeter, I'm going to click in the interior just to let it know that I only want stalls towards the inside. Then I'll get my set of grips here, and I'm going to switch up my line segments, and I'm going to change them to arcs. Notice that when I make these changes, though, it does update the stalls as well. So now I have my perimeter laid out pretty quickly. What I can do is I can use a parallel option, and I'll actually create parking spaces and parking rows parallel to what I've already made, and at the same time abide by the standards by making the driving width the right width. Once I'm done laying this out, you have our lot in place. When I finish this, you'll see that we actually have like an irregular perimeter. So this may not be the best option to go with, So I'll show y'all how easy it is just to switch up a different design and lay in something new. So for this next one, I'm going to go ahead and switch it up and put a new row up here at the top that'll be parallel. And then I can use my grips to shorten or extend the row if I need to. And I can even adjust the geometrics of the end base here. Now once I have this one in here, I can go ahead and lay down a parallel row option now a lot easier, and it'll look a little better. And I'll switch up the grips here. And then I'll use the parallel option one more time so that I can get this other rows in here. Once I'm done laying in my spaces, I may want to start considering putting in some handicap spaces. And I'll go ahead and convert some of these bays over here next to this building entrance. It'll be as easy as doing a point and click to make these changes. Notice that as I make these changes from normal to disabled, the parking spaces will dynamically update as well. Now that I'm done laying out a lot, we may want to check out, where we're at, how many total spaces we have. We can do that by generating a parking report. When I generate this parking report, it'll list out a tally of the total amount of stalls, and we can even see how many disabled ones we put in. You can see that the total amount is 157 and the disabled count is 6. Now once we're finished, we may want to further optimize the layout and adjust certain things as the parking angle. Even though if I do this, it will reduce the total amount of stalls, but will provide more of a driving space in this tight area. So I'll go ahead and make the entrance stalls 45 degrees, and they will match the driving direction. And then at the same time, you'll see how it dynamically changes and abides by the standards. I'll go ahead and switch up some of these rows right now. And I'll change the bay angle to be 45 degrees here. And I'll also do it for this row down here. And just like that, we tested out in the design layout. Now we can generate a parking report again just to compare it to the results of our last design. And you can see that the total amount of stalls went down to 147. So now you can see that vehicle tracking allows us to make parking lots pretty quick, and it's easy, and as you can see, it's pretty efficient as well. I'll go ahead and switch over to our last example. So far, everything we've been checking out has been in a horizontal perspective. I'll go ahead and incorporate elevation into the analysis now. In this example, we see a civil 3D corridor model. We want to see if our large vehicle can maneuver through the intersection successfully. We have a swept path that's already been created, and it seems like the horizontal solution is going to work. But we need to check out how it'll work vertically. So first things first, we're going to make a little profile of our vehicle just to see what we're working with. Once I make this profile, I'll see that the lowest part of this vehicle here has a ground clearance of maybe less than 6 inches. And then we have 2 points at which the vehicle will pivot. So now we know what we're working with, and we can check out outlines of the driving path to see if it'll make the maneuver around the corner. So I'll lay out those outlines right now. Once I've laid these out, we can see that the lowest part of the trailer is directly above the crown of the road, and at the same time our tires are at the lowest area of the pavement. This means that there's a possibility that the truck can make contact with the road surface. To determine if we have a problem or not, we can easily run what is called a ground conflict report, and it'll tell us what is going on. Once I run this report, it'll show up in our swept path, and it will show to what extent our vehicle will impact the crown of the roadway. Using information that vehicle tracking provides, we're in a better position to make decisions to resolve the situation. And now I'll switch it back over to Jeff.
All right, thank you, Tony. So to summarize, we've seen today that vehicle tracking is a comprehensive transportation analysis and design solution for vehicle swept path analysis. Tony was able to show us how easy it is to evaluate movements of various vehicles in different project scenarios and how quickly we can lay out a parking lot using the tools within vehicle tracking, all while adhering to vehicle and parking standards from the robust library. We were also able to quickly evaluate alternative designs in that parking lot to determine the most efficient and practical way to move forward. Autodesk Vehicle Tracking is an easy-to-use, very intuitive, and extremely powerful software. It works in a familiar AutoCAD environment, and it helps speed up planning and design processes to more quickly evaluate design alternatives. I would like to thank everybody for attending ECAD's webinar on vehicle tracking today. For more information on vehicle tracking, please contact your local ECAD office. We're going to leave the session live for a few more minutes just so you have time to submit any questions that you might have. We'll address those again after we're done. So just submit them through the chat window. And I hope everyone has a great rest of the day.